Okay, check this out. The other day I had to generate some data that was going to be representative of cars driving on a long road where each of the car speeds was going to raise and lower in such a way that the values didn't spike. You wanted it to actually look like a car actually driving that's accelerating and decelerating. I put together a shadow traffic config to do just that, and this is a visualization of the output. This is in Grafana. This is 20 different cars. Each car is emitting its speed once every 200 milliseconds, and there are thresholds on this graph where if they cross up to certain speeds, their chart will go red, and if they cross into a lower speed, it will go yellow and all the way into green. And you can see these changing, and more specifically, you see these peaks and these valleys. None of these cars are just wildly spiking around. They're changing their speeds, but they're not just spiking off to unpredictable values. I want to show you how I did this with shadow traffic. It's actually quite simple. I put together a little config file. This generates data to Postgres because it's easy to visualize with Grafana. I create 20 different forks to represent those 20 different cars. And then all I do is record the unique car ID, which is the fork key defined here above, timestamp for when it's currently emitting. And then I set up a really simple state machine with only two states, start and next. And next just loops on itself, so it constantly emits new updates. The first state is start. It emits a random value of about 50 miles an hour with a standard deviation of 5 miles an hour. And then the next state, all it does is it takes the previous speed and it adds on a delta of anywhere between negative 3.5 and positive 3.5. And then we clamp it so that it never goes slower than 35 miles an hour or above 70 miles an hour. And that's actually all you need to do to create a really nice graph of speeds that are coherent and connected across a large fleet of vehicles.